Building an AI agent depends on your ability to solve a memory problem before you can even utilize the model's reasoning capacity. Without a way to retrieve specific information, the model is trapped within the limits of its training data. The intuitive approach is to take every HR policy, product manual, and legal contract a company owns and containing the word vacation, because it lacks the logic to recognize that the two concepts are related. AI requires meaning-based matching to understand intent, a requirement that changes how we think about the underlying search infrastructure. This meaning-based matching is achieved through vectors, also known as embeddings, which serve as the mathematical language of semantic search. Embedding models translate unstructured data into lists of numbers, representing coordinates in a multidimensional space. Because these capture semantic relationships, related concepts naturally group together. Vacation, time off, and PTO end up in the same neighborhood, distant from unrelated data. In a RAG system, the LLM uses this spatial grouping to retrieve the most relevant context to answer a user's question. It acts like an open book exam, where the AI finds the correct chapter before it begins to formulate a response. While the math of vectors is consistent, the challenge for developers is navigating a market filled with different database architectures to find the one that fits their production needs. Before evaluating specific database software, you must address the data preparation step that dictates the success of the entire pipeline: chunking. There is a direct trade-off between context and precision. If you chunk documents into large segments, you retain the broad theme, but the LLM loses precision sifting through irrelevant noise. Conversely, if chunks are too small, matching becomes highly precise, but the AI loses surrounding context. A practical baseline is 300 to 500 tokens, with a 50 to 100 token overlap to ensure context isn't lost. Even the most expensive auto-scaling database is ineffective if it is fed poorly chunked data that lacks clear semantic boundaries. Once the data is prepared, the choice of infrastructure depends on the current stage of your development. ChromaDB is often the first choice for local development because of its zero-friction setup and direct integration with popular AI frameworks. Chroma works as an entry point for building a working prototype in under an hour, though it is not the primary choice for applications managing high-volume production traffic. For developers who require higher performance and more control over the tech stack, Qdrant serves as the professional alternative. Written in Rust, Qdrant is optimized for speed and memory efficiency. Being open source, it allows you to avoid recurring SaaS vendor fees. The trade-off with Qdrant is the technical overhead. By choosing to self-host, your team becomes responsible for managing and scaling the Docker infrastructure yourself. The choice between Chroma and Qdrant centers on whether your team prioritizes setup speed or direct infrastructure control. As applications move into public-facing production, the focus shifts towards enterprise-grade scaling and reliability. Pinecone has become a dominant player by offering a fully managed, auto-scaling service that removes the need for manual server maintenance. The cost of this convenience is a loss of architectural control and a commitment to escalating vendor pricing as your data volume expands. Weaviate offers an alternative for enterprise use cases that require hybrid search. Hybrid search allows you to run semantic vector similarity and traditional keyword matching in parallel. This is useful when you need the AI to understand concepts while also being able to find specific identifiers like SKU numbers or legal codes. This capability introduces complexity. Using Weaviate effectively requires a more involved query architecture and continuous tuning to balance the weights of the two search methods. Choosing an enterprise database is a trade-off between ease of deployment and the engineering resources required to manage complex query logic at scale. While RAG is the most prominent use case, vector databases are not limited to text-based chat applications. Spotify and Netflix use vector similarity to power content recommendations, converting your listening habits into coordinates that are matched against millions of songs or movies. In cybersecurity, these same models help detect network anomalies. When a specific behavior deviates from the cluster of normal traffic patterns, it triggers an alert. The core logic remains the same: convert data to math, store it for similarity search, and retrieve it for decisions. Navigating these options requires matching the specific database to the current phase of your project. For learning and proving concepts quickly, ChromaDB is the recommended start. For backend speed and self-hosting, Qdrant is the logical choice, and for zero-maintenance scaling or hybrid support, Pinecone and Weaviate are the standard enterprise paths. Success in AI building is less about picking the perfect database on day one and more about establishing a robust data chunking strategy that can grow with your application.